Ron Shook here to work through with you some ways to solve questions about radioactive decay and in particular about half-life. So there are some questions you were given to answer, solve today in class. One of the ways I go about solving these is I make myself a little chart, and the top part of that chart is how many half-lives has a substance gone through, and below that is the percent of the original element that remains. So I just put a number of half-lives. I label them in order 1, 2, 3, 4, 5, 6. Remember, a half-life is an amount of time, and that amount of time is specific to certain elements. Then below that, each time we go through a half-life, we end up with half of the original material being in that form and another half that has decayed to a new element. So the percent of original will go from 50 to 25, 12.5, rounding off to 10, 6.3, 3.1, and 1.6. Now, those of you that have the math skills of Powers, that comes out to what I just did. For those of you that would like to, the percent original is equal to 100 divided by 2 to the nth power, where n is the number of half-lives. So our first question goes like this. 25% of a radioactive substance remains in a rock sample, while 75% has decayed to a new element. How many half-lives have taken place? Well, if we have 25% of the original element remaining, 2 half-lives have taken place. The next question says, if the original rock was U-235, how old is the rock? That's where you'll need to go to the half-life chart that I've shared with you. I've copied the relevant information here. U-235 decays to lead-207. One half-life is 710 million years. So if I've got a substance that has undergone 2 of these half-lives, it would be 710 million years times 2. The third question, a bone is found in some sedimentary rock. When analyzed, the bone is 12.5% C14 and 87.5% nitrogen 14. How many half-lives have passed? So again, we have 12.5% of the original, and that means 3 half-lives have passed. The next question will be, how old is the bone? Well, we need to know what a half-life of carbon-14 decaying to nitrogen-14 is. The value I found was 5,730 years. So 5,730 years times 3 half-lives will give us our answer to how old that bone is.